Hello dear students, I think that all of you are well. Today I am delivered a good lecture. Chapter name is Newtonian mechanics. Okay, already we have discussed a lot of the things from the special part moment of inertia. We already find out moment of inertia for different shape of the object. Now I just try to list it which type of the object already we have completed. Okay, my dear student, already we have completed to find out the moment of inertia. Number one, in case of uniform rod, this is the uniform rod. If the length of the uniform rod is L and if the mass is M, and if rotational axis passing through the side of this uniform rod, then moment of inertia will be I is equal to M L square divided 3. Number two, if the rotational axis passing through the mid side and perpendicular with the length, suppose this is the length and M is the mass. In these cases, the moment of inertia will be M L square divided 12. Number 2. Number 3, if this is the rectangular shape of the object, rectangle, and this is the normal. Try to understand, rotational axis will be normal in case of the rectangular shape, and this is the direction of the rotation. Suppose this is the L and this is the B. B is a width, B is width, L is a length. Okay, in these cases the moment of inertia will be I is equal to M divided 12 L square plus B square. In our previous lectures already we learned. Okay, in case 2, 3, 4, in case of circular disc, if this is the normal, if rotational axis is a normal, suppose R is a radius, M is a mass, then moment of inertia I will be M R square divided 2. Okay, my dear student, try to understand, in case of the circular disc, moment of inertia will be different for different axes. As this is the normal, because of that reason moment of inertia will be M R square divided 2. But if this is the diameter, suppose this is the circular disc number 5, if rotational axis is a diameter, then moment of inertia will be M R square divided 4. Okay, in case of cylinder, suppose this is the cylinder, this is the rotational axis. Okay, R is the radius and L is the length, or M is the mass. In case of the cylinder, moment of inertia will be same, M R square divided 2, as like circular disc in case of the normal axis. My dear student, this is the basics rules. One is rectangular uniform rod. If the rotational axis passing through the side of the rod, then moment of inertia will be ml square divided 3. If the rotational axis passing through the mid side and perpendicular with the length, then moment of inertia will be I is equal to ml square divided 12. And in case of the rectangular shape of the object, if the rotational axis is a normal and passing through the center of the object, then the moment of inertia will be I is equal to m divided 12 L square plus B square. L means length, B means width. In case of the circular disc, uniform circular disc, if the rotational axis passing through the mid side and normal, then moment of inertia will be I is equal to m R square divided 2. This is the same in case of the solid cylinder. This is the solid. Try to understand, this is the solid. And in case of circular disc, if the rotational axis is the diameter and this is the direction of the rotation, then the moment of inertia will be I is equal to m R square divided 4. Okay, already we learned this basic shape. Okay, in our section moment of inertia are different type of the shape. Next lecture I am trying to understand. Now we just try to apply the parallel exist theorems for making a different type of the rules, for making different type of the moment of inertia for different type of the exist. Now we discuss. At first we discuss first. My dear student, already we learned moment of inertia. If this is the length of the object and m is a mass, if this is the rotational axis passing through the side of the object, then moment of inertia will be m L square divided 3. Okay. Now we try to find out this equation I is equal to m L square divided 3 by applying parallel exist theorem. So parallel exist theorem is very powerful theorem. We can find out I is equal to m L square divided 3. How we can find this? Try to understand. Suppose this is the uniform rod and the length of this uniform rod is L and m is the mass. M is mass and L is length. Okay. Before applying parallel exist theorem, at first we find out the moment of inertia who is passing through the center of the uniform rod. Suppose this is the center of uniform rod, that means center of the gravity. Okay. Suppose this is a rotational axis. This rotational axis passing through the center of the gravity and perpendicular with the length. That means this rotational axis divide the uniform rod into two equal parts. So we can write moment of inertia I is equal to m L square divided 12. In our previous lecture we learned this. So we denoted this Iz. Why we denoted this equation by Iz? Because G means center of the gravity. G means center of the gravity. Okay, Iz means the rotational axis passing through the center of the gravity, and as the rotational axis passing the mid side and perpendicular with the length, so we write this. Okay. Now we apply parallel exist theorem. How we can apply this? At first we draw a parallel, any kind of the parallel from this x prime axis. Any parallel axis you can find moment of inertia by applying parallel exist theorem. Now we apply here parallel exist theorem. This is very powerful theorem. Suppose this is the parallel axis of x prime, C, D. Now our duty is to find out the moment of inertia with respect of CD. Okay. Already we learned if the rotational axis passing through the side of the object and perpendicular with the length, then m L square divided 3. Now we find this equation by applying parallel exist theorem. Our duty is to find moment of inertia from CD axis. Okay. At first we write the moment of inertia which is passing through the center of the gravity. Okay, this rotational axis passing through the center of the gravity. Because of that reason we learn Iz at first. Then we write plus sign, and we know all the mass of the object is concentrated on center of the gravity. Suppose the total mass of the uniform rod is m and this mass concentrated on center of the gravity. We consider total mass m concentrated here. Okay. The perpendicular distance between the two parallel axes, if the total length is L, then this distance is equal to L divided 2. Our equation is, now we write here m and multiply h square. This is the equation of parallel exist theorem. Now we put the value here. The value of Iz is m L square divided 12, and we put the value of L. L is L divided 2. After solving this equation, m L square divided 12, m L square divided 4. Now we take LCM. M L square plus 3 m L square. So 4 m L square divided 12. Now we get here I is equal to ml square divided 3. My dear student, you just think what is actually happened here. Same things is happened, and as CDX is passing through the side, so the moment of inertia will be ml square divided 3. Okay. Now if the rotational axis passing, this is the rotational axis. Okay, this is rotational axis A, B. Now our duty is to find out the moment of inertia for A, B axis. Okay, A, B axis. Our question is, what will be the moment of inertia in case of A, B axis? If this body, the diagram will be like this. Suppose this is the diagram and AB is the rotational axis, then what will be the moment of inertia? Try to understand. If the total length is L and this is L divided 2, this is L divided 2. Now if we apply parallel axis theorem, already we learned moment of inertia for x prime axis or IZ. So we write here AB, IAB. Our duty is to find out moment of inertia with respect to AB. Okay, because of that reason we write here IAB. Our duty is, at first we write IZ, then we write M and H square. What is the value of H square? This is the value of H square. Okay, H is equal to, if this is L divided 2, then this will be L divided 4, half of L divided 2. So we put here the value of IZ, ml square divided 12, ml square divided 12 plus m L divided 4 whole square. Okay, now ml square divided 12 plus ml square divided 16. Now we take LCM, 12 into 16, 48. LCM will be 48. So 4 ml square plus 3 ml square, 7 ml square divided 48. This is the moment of inertia with respect to AB. So if we able to apply parallel axis theorem, then we can find moment of inertia for any kind of the axis. Okay, now I take a questions and try to solve. Okay, my dear student, our problem is suppose this is the uniform rod, this is the uniform rod, this is uniform rod. Suppose the length of this uniform rod is, the name of the uniform rod is AB, and the length of AB is 12 centimeter and mass is 4 kg. Try to find out the moment of inertia for x prime axis if this x prime axis divide AB into 1:3. Okay, our question is the length of the uniform rod AB is 12 centimeter and mass of the uniform rod is 4 kg, and if the rotational axis x prime divide the AB rod, uniform rod 1:3, then find out the moment of inertia with x prime axis. This is number 1. Okay, at first we try to solve this problem. Solution: if we find out moment of inertia x prime, then we can apply here parallel axis theorem. At first we write IZ. IZ means the axis which is passing through the center of the gravity and divide the AB section into 2 equal parts. Suppose this is the IZ. Okay, this is Ig. Already we can write the equation of Ig. The equation of Ig will be ml square divided 12. Already we learned if the rotational axis passing through the mid side and perpendicular with the length, then this will be ml square divided 12. Okay, now our duty is to find out the total mass. We know the total mass is m, that is concentrated on the center of the gravity, and our duty is to find out this h distance. Suppose this is the c. Okay, now our duty is to find out the value of h. After finding the value of h, then we put here, then we find the moment of inertia with respect to x prime axis. So at first we write here Ig, the value of Ig, m L square divided 12 plus m. Now our duty is to find out the value of h. We learned here AC part. At first we try to find out the AC part. AC part is 1 and CB part is 3. So at first we find out AC part for the fractional law. Okay, AC part is 1, so we at first we write 1. The summation of the total ratio will be 1 plus 3 into the total length of the object is AB. AB means 12 centimeter. So we get the value of this 12 divided 4, 3 centimeter. Okay, 3 centimeter. Now if this is the 12, L is 12 centimeter, then this will be the 6 centimeter and this will be 6 centimeter. Okay, so h, value of h will be 6 minus 6, that means 3 centimeter. Okay, so value of h will be 6 minus AC means 3, total 6 centimeter, AC 3, so this part also 3 centimeter h square. Now we put the value, m is 4, L is 12, 0.12 centimeter, turn it into meter, 12 meter divided 12 plus m is 4 and value of h is 0.03 centimeter, meter 0.03 meter. Okay, my dear student, you just calculate and get the value of moment of inertia in case of the x prime axis. My dear student, I think that all of you clearly understand. If you fail to understand any kind of the part, then please write your comment on the comment section. I am trying to repeat this first again. Okay.